Hello everyone. In the last video, we discussed basic calculations and brief introduction of plot command in Mathematica. Here we are going to discuss some more features of Mathematica. We'll cover vectors, matrices, tables, manipulate command, limit, integration and differentiation of a function, parametric curves, plots in polar coordinates and three-dimensional plots. Let's first discuss vectors. A vector in Mathematica is expressed as a list. For example, a vector in 3 dimension can be written as, I take an example of a vector 1, 2, 3. So I type here 1, 2, 3 and put this in a curly bracket. I name it as Q. So Q is a 3-dimension vector. Now again I type another vector in 3 dimension and name it as W. Again in curly brackets I write, for example I take vector to be 2, 0, 4. So now to add these two vectors, Q plus W, so I get the output as scalar multiplication in vectors can be obtained by typing. Suppose I take scalar to be 3 star Q, so it gives me the scalar product of vector Q with 3, and dot product can be obtained by typing Q dot W. It will give us the dot product of vectors Q and W. Now to take cross product, we type cross and within square brackets I type the vectors of which I want cross product. So I write Q and W separated by comma and press shift enter key. I'll get the cross product of Q and W. Next, to find norm of a vector, I type norm of, suppose I want to find norm of Q, so I will write norm with capital N and within square brackets I type Q, so I get norm of Q. Now let's move to matrices. A matrix in Mathematica can be input as, suppose I want to define a matrix A whose first row is 1, 2, 3. So I write A as, within curly brackets I write 1, 2, 3, and for the second row again I write in curly brackets 2, 3, 1, and the third row, because I am going to type a 3 by 3 matrix, so it is let's take it to be 1, 0, 1, then and I put all these three rows in again in a curly bracket. So it will give me a matrix this, whose first row is this list and second row is this and the third row is this. Now to view a matrix in this form is a little difficult. The command matrix form will produce a formatted rectangular matrix with the lists in the brackets as rows. So if I give matrix form with M and F capital and within square brackets I type capital A, then it will generate a matrix in this form. And to obtain inverse of a matrix, the command is inverse A. Now if I want inverse of A in matrix form, I'll type here matrix form and within square brackets I'll type inverse A. So In this way, I get the inverse of A. It is in matrix form. Now to find dimensions of matrix A, the command is dimensions, and in square brackets I type A. So I get the dimensions of the matrix to be 3 by 3, and to find determinant we type dt with D capital, and in square brackets we type the matrix of which we want to know the determinant. So the determinant comes out to be -8. Eigenvalues and eigenvectors of a matrix can also be determined in Mathematica using eigenvalues command and eigenvector commands. So now to find eigenvector, I'll type, so let's first find eigenvalues of A. So it will generate eigenvalues of the matrix A. To write the eigenvectors, I'll type eigenvectors and of matrix A. So it gives eigenvalues of matrix A. In the Wolfram language, many kinds of data are stored in tables. You can generate the tables by evaluating an expression for sequence of parameter values. Table command allows you to construct a table, as I'll show you by giving an example. So suppose I want to generate a table of squares of first 10 natural numbers. Then I'll give command table with capital T, and within square brackets I'll type x square and next comma and give the range x comma. I want to generate squares of first 10 natural numbers, so I'll type x comma 1 comma 10. So when I press shift enter key, I get the squares of the 10 natural numbers. It is often handy to produce a table of function values for various inputs. For example, I consider a function f x underscore within square brackets colon and equal sign, and then I press the function I wish to define. Suppose I define the same x square. Okay, so now if I want to generate a table, I'll give table f within square brackets f and function of x comma the range of x from 1 to 10. So in this way I'll get the value of fx where x is varying from 1 to 10. Like in plot command, the table command also takes two arguments separated by comma. The first is the formula or the function, while the second is a variable. However, the values of the variable will increase by 1 by default in table. You can see from here that x is taking 1 and then 2 and then 3. So the values of the variable x will get increment by 1. So if you want to give, you can give step size, like for example I type table within square brackets the same function x and comma x in curly brackets. If you wish, you can start with any other number, like now I start with 5 comma up to 100. and I give an increment by 5 this time. So here I get the table with starting with 5, x is starting with 5, square of 5, and then getting increment by 5. So 10, square of 10, and 15, and square of 20. You can make a table that displays the values for the multiple functions. For example, if I wish to generate a table with first entry as x, and second as x square, and then third is x cube, and next x power 4 for x, say taking values from 1 to 10, then I will give the command. I name that table by tab, and I give the command tab table with capital T, and within square brackets I make a list of functions I wish to generate: x comma x square, x cap 2 comma x cap 3 comma x cap uh, cap 4, and out of this curly bracket I type second argument, that is the value of variable within curly brackets x comma 1 comma 10. So if I press shift enter key, I'll get this table. I gave here grid command, grid, and inside square bracket I type the name of table. So here by giving grid command, the table by giving grid command, the table display each inner list into a row. So the first list is the first row, second list you can see that it becomes the second row of this grid, and so on. Now next let's move to manipulate command. Manipulate is a dynamic interface with sliders that can be manipulated in real time. If I type manipulate in place of table, I'll show you. Manipulate in square brackets, I type the same function x cap 2 comma the range of x, x varying from 1 to 10. Here I get a slider. You can move the slider with your mouse, and um, to control the value of x, and you can see the value of function in the output field. This is an interesting to play with it. There is a plus sign on the right of the slider. If you click on that, you can see the value of x at which the value of the function is displayed. You can even type a value of the variable x in the input field. For example, I type here 5. So when I press enter, I get the value of the function in the output area. Okay. So here I give you an interesting command. Manipulate plot sine. Suppose I want to make a graph of sine 1 by x, x varying from say minus 1 to 1. So then for that I'll give this command. Without manipulation it will look like this. I'll show you. Plot within square brackets I type 1 by x and out comma the range of x, x varying from minus 1 comma 1. So it will give me this plot. Okay, if I type manipulate command with this, manipulate, and then I keep all these things in a square bracket, and in place of -1 to 1 I type here -n to n, and out of the square bracket I type within curly brackets I define n from -1 to 1, say. So I write n comma -1 to 1. So when I press shift enter key, so I get this. So by sliding, using this slider with your mouse, you can see. If you give a plot range command here in the plot command, so plot range with capital P and R, range arrow, and say 5, then you get this. Plot range is to maintain a fixed viewing rectangle. Okay. So here you can use 2 or 3 controllers in manipulate command. For example, if I can introduce one more controller over here, I type sine 1 by x plus a, where I give the range of a after the range of n. So for this I type within curly brackets a comma, for the range of a I give say -2 to 2. So when I press shift enter key, I'll get the 2 sliders. One is for a, you can see the curve is moving as I move the slider, and this is for the value of n. Okay, so here are some more interesting things that you can do with manipulate command. You can drag over the color field to adjust the color continuously. So for that I give this command, say I type here manipulate, within square brackets I type plot, again in square brackets I type capital S for sine, capital SIN, and within bracket sine 1 by x, and I give here the range of x. X is varying from say -n to n, and here after the curly bracket I give plot range with capital P and R, range, right arrow by pressing minus and greater than sign, and color I give the range for n. Let me take it to be n varying from -1 to 1, and then again out of the curly bracket I type comma, and color I give as red. I keep these two in curly bracket separated by comma, and then press shift enter key. You can see, yes, here you can see clearly that this is the slider for n, and this is for the color bar. You can change the color, whatever color you want, you can choose by uh, moving your mouse on this slider. One more thing I want to tell you, that one should clear an assignment once you are done by giving clear command, as we defined earlier. A f Q and W. So we can give a clear command to clear these functions and assignments. So I give clear, within square bracket I type F, and I can also type I can clear many assignments together in one shot by typing within square brackets and separating by comma. So I type F comma A, sorry, Q we defined and W we defined. So I can give this command to clear uh, F, Q and W. The next, to find limit of a function, so I type F within square brackets x underscore followed by colon and then followed by equal, and then I type the function cos with capital C, within square brackets I type x and plus x square. So this is the function I have chosen. Now in the next cell I type, uh, suppose I want to find limit of this function when x is approaching to 0. So for that I type limit with capital L, and within square brackets I type fx, the function, and comma uh, x, right arrow key, and then 0. So it will give me the limit of this function. Next, to integrate this function, I give the command integrate, uh, in square brackets I type f x, the function, and the variable x. So it will give me the integral of fx with respect to x. Now if I wish to integrate to find a definite integral of f, when x where the limits are 2 to 5. So for that I will give the command integrate in square brackets I type fx comma I give x 2 to 5 within curly brackets separating by comma. So when I press shift enter key I get the integral of this function from 2 to 5. Next, for the differentiation, for the derivative of a function, the Mathematica syntax matches that of traditional mathematical notation. For the function defined above, if I wish to find derivative of that function, I simply type f dash and in square brackets I write x. So it will give me the function derivative of this function cos x plus x square. So it's 2x minus sine x. Okay. Here now, there is another way to take derivative of an expression with Mathematica, which is useful in many situations. Uh, that is fd of f within square brackets x, and the variable with respect to which we want to differentiate f. So it is this. Suppose we have a function of several variables. Let's take a function h, function of two variables, say x and y, x underscore comma y underscore, and equals cos of, so here we must close this square bracket, and cos x plus exponential y. So for that I write e capital xp small, and within square brackets I type y, and so in this way I define a function of two variables e power y cos x. Now if I wish to find derivative of h with respect to, say, y, so for that I give the same d command d of h. H is function of x and y. So in square bracket, after typing h, I type x and y, x comma y, and out of the square bracket I type the variable with respect to I want to take the derivative. So I type y over here, so I get the second derivative. Higher order derivatives can be obtained by typing f double dash within square bracket I type x, so I get the second order derivative, and to get the third order derivative I type three dashes, and then within square bracket I type x, so I get the derivative, third derivative as sin x. Now let's move to parametric curves. Since parametric curve uh, is a vector valued function of variable t, so we define a function. Let's define it, a function of t uh, colon equals, and then since a vector at Mathematica represented in a list, so a parametric curve is defined as a list of two real valued functions. The first function represents x coordinate and the second function represents the y coordinate. So for example, I take here the first function to be cos t plus t, and the second to be sin t, and so in this way I define function g. Now to plot parametric curve, we give command parametric plot within square brackets I type gt, the function g of t, and here I give the range of t. Suppose the range I take from 0 to 4 pi, so I type 0 comma 4 space, and for pi, since pi is a inbuilt function, so it will start with capital P, so I type pi small I, and I give the plot style P and S with capital, plot style arrow key, and then I gave it red, so it will draw a parametric curve of the function g. Now there is another way to plot parametric curves. Suppose I write x1 equals the first function. This time I take cos in square brackets t plus 5 into cos t. So I give, for multiplication I can give a space between 5 and cos. So I type 5 space cos with capital C and 3t. Suppose I wish to type 3t. So I type 3 space t, and in the for the next function I type x2 equals 6, take 6 cos t minus 5 sin, say 3t, 3 space t. So I have defined x1 and x2. Now I give the command parametric plot within square brackets Now I type x1 comma x2 and in curly brackets comma the range of t. I take t varying from 0 to 4 pi. So I type t comma 0 comma 4 space pi. So and I give the plot style comma plot style arrow and red. So when I press shift enter, I get the parametric curve of this function. Now let's move to plots in polar coordinates. The built-in command polar plots can be used to view the graphs of polar functions. For that, first I define a function f1 function of theta. To type theta, I give command backslash and in square brackets I type theta with capital T, T-H-E-T-A. So in this way you can insert theta. You can also insert theta by clicking on insert menu on the menu bar. When you click on insert menu, click on special characters, then their special characters appear on the right panel. Here there is an option of Greek letters. When you click on Greek letters, you can insert theta from here, or otherwise you can type the command I told you. After typing theta, we type underscore and then colon and followed by equal sign. Now I define, suppose I define f1 theta to be theta. So again I type theta by typing backslash square bracket theta with capital T. So here I have defined the function f1. Now to plot this, I give the command polar plot with two capital P's, and within square bracket I type the function to be plotted f1 function of theta. So I type backslash in square brackets theta and comma, and in the curly brackets I give the range of theta. Again I type theta comma 0 to 10. Say out of this curly bracket I type axis arrow key and false, and then I press shift enter key. I get the plot of the curve f1. Okay, axis is an option that specifies whether axis should be drawn or not. So here I have given axis false, so no axis appears over here. Like in plot command, in polar plot command, also we can draw multiple functions simultaneously. For that I need to define one more function, say f2. So for that I define f2 within square brackets. I type theta underscore and colon followed by equal sign, and this time I define function to be theta and plus sign of theta square. So I have defined function f2. Now I give the polar command, polar plot command. Polar plot in square brackets I type the list of functions f1 function of theta comma f2 Again I have to type theta within square brackets, so I just copy this and paste it over here. Okay, now out of this curly bracket I give the range of theta in curly brackets. So I type within curly brackets backslash within square brackets theta, comma, suppose I take the range of x theta to be 0 to 10, and then after typing the range of theta I type plot legend, and then arrow key, and within quotes I type expressions. So when I press shift enter key, I get the both the curves for the function f1 and f2 in same set of axes. Okay, so polar plot accepts almost the same options as accepted by plot command. Now let's move to three-dimension plots. Suppose we have a function. Let's take it as g1 a function of two variables x and y. So I type x underscore comma y underscore, out of the square bracket I type colon followed by equal sign. I choose the function to be sin x plus cos, within square bracket I type y. Okay, so now I have defined this function. To get a three-dimension plot of function g1, I give the command plot 3d. I type plot 3 with capital D, within square brackets I type the function to be plotted g1, and it is function of x and y, so I type x comma y in square brackets, and out of this square bracket I give the range of x in curly brackets, x varying from, let's take range of x to be -2 to 2, so I type the -2 comma 2, and for the range of y we choose -1 to 1, and when I press shift enter key over here I get the 3D plot of the function g1. Once you have generated this plot, you can rotate this with your mouse and view it from different angles.